Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and concepts of coordinate geometry. So let's start. So if you would refer to my earlier video, we had talked about the distance formula or how to use Pythagoras theorem when it comes to calculating the distance between any two points which have been represented on the Cartesian plane. Now in this video, we will be basically talking about two things. One is we'll be talking about the slope concept, right? So this is one thing that we are going to talk about. Next, we will be talking about how to use the slope concept when it comes to the section formula, how to use that, right? Let's start. Now, when we are talking about the slope concept, now slope, what is slope? So if I draw a line, so let us say if I draw a line, then only the concept of slope comes into picture. And let's say I have drawn 2 points and I have connected the points with the help of a straight line. So this becomes a line segment. So let's say this line segment is AB. Now I can increase, now this is my point B. Now I can increase the height of this point B, keeping, so when I increase the height of this point, this gives rise to another point. So another point, at least one more point. Now when I'm increasing the height, I'm keeping point A as constant. That means while increasing the height of point B, increasing the height means now perpendicular. Similarly, I can increase the height further. Right? And then I can keep on increasing the heights thereafter. So let's say these points are, so let's say now I want to increase it substantially. So let's say now this is another point that has been formed. So now let's say this is E. And then finally I take it to a substantial increase. Let's say I take it to a point F. Now the point that I am trying to discuss here is, other than the points that I am mentioning here, can I say that if I project a point upwards or downwards? So here projection could be, I'm projecting this point up, so it will travel through the same trajectory. Now when I'm projecting this point upward, what I'm trying to say basically is point B, point C, point D, point E, point F, they all lie on the same line. They do not lie on different lines. So when they are lying on the same line, what I intend to convey is all of these points. Which points am I talking about? The projections of the point B upwards or downwards. I mean, I could have accordingly taken them downwards also. It does not make any difference when it comes to understanding it conceptually. So what I intend to convey here is all these points are collinear. So there is a terminology that I am bringing here is collinear, collinear, linear, straight line. So when two or more points lie on the same line, we call it as collinear points. Okay. Once we have done this, now you would see the angle. So if I talk about the angle CAB, then I can talk about the angle DAB, and then I can talk about the angle EAB. And last but not the least, I can talk about angle FAB. Let's say these angles are A degrees, B degrees, C degrees and D degrees. So can I say this angle is formed because there is a change in the Y component. Y component is as you go up. We basically talk about the Y axis as we go up, and that too perpendicularly up. We are talking about the change in the Y component. And because of the change in this Y component, now if I say keeping the change in the X component same, what I intend to say here is, if I say that this is a straight line, let us say this, I have taken it as an X axis, or I have taken a line which is parallel to X axis. Now when I am taking a line parallel to X axis, what I can say here is, now what are the coordinates for B? Let's say I take it as, okay, let me start the discussion from A. So if I take this point as x comma y, Now here I will want to take it as x1 comma y. If I say that this is a line which is parallel to x-axis, so I am assuming that AB is a line which is parallel to x-axis. This is what I am assuming when I am drawing this inference, the inference that I am going to draw. So wherein these are the angles that which are being made, right? So can I put it like this, that no, so we know that, can I calculate tan of A degrees? Tan of A degrees is just like saying perpendicular upon base. Now the perpendicular part here is how much? CB, and what is the base? AB. Now what is this? This is the, now so we are basically talking about the line segment CB. Now when I am talking about this perpendicular on this perpendicular, let me assume that this is the line which is parallel to y-axis. So I am assuming that the line FB is parallel to y-axis. These are the two assumptions that I have done for the discussion which is taking place here. Now when I am talking about this, can I say that now the length of CB, so for if I am going up on a line which is either the y-axis or a line parallel to y-axis, as discussed in my earlier videos, what is going to change? Something that is going to change here is the x component remains the same, which is abscissa, but the ordinate changes. So let's say x1 comma y1, for D x1 comma y2, for E let's say x1 comma y3, and for F let's say x1 comma y4. So what is the length for CB? The length for CB will be nothing but the perpendicular distance only, which is y1 minus y, divided by the horizontal distance, which is AB. So the horizontal distance will be what? x1 minus y. And the same you can infer for others. Now this rate, this is the rate of change. Tan theta is the rate of change, which is perpendicular upon base. This gives you the slope of the line. So we are talking about which line? We are talking about the line AC. So this gives you the slope. Let's say slope is denoted by M for the line AC, and the line angle, the line AC makes an angle A degrees with the line BC. Similarly, can I say tan of B degrees is equal to the perpendicular, which is DB, upon the base, which remains the same in all the cases? So this can be understood as y2 minus y, this is x, divided by x2 minus x, which is just like saying slope for the line AD. Similarly, can I say tan of C degrees? C degrees is nothing but EB upon AB. Now what is the length for EB? It's nothing but y3 minus y divided by x3 minus x, which is equal to the slope of the line AE. And the last but not the least, I can say tan of D degrees is equal to how much? So we will say this is nothing but FB divided by AB, which is to be written like this is y4 minus y upon x4 minus x, and this is nothing but the rate of change of height, the rate of change of height versus, the change of height versus the change of base. So the rate of change of height versus the rate of change of base. Okay, so which is nothing but, we can say this is nothing but slope of AF. So I hope by now you would have understood slope comes into picture only when the y component changes along with the change in the x component. That is how slope is ascertained. Now once you are able to ascertain this, the next point which arises here is, what is the slope for the x-axis and what is the slope for the y-axis? So if you recall, last time we had talked about that the equation of the line, which is x-axis, is written by y is equal to 0, and the equation for y-axis is given by x is equal to 0. I hope there are no doubts about this. And at the same time, we know that this is the positive side of x-axis, which is positive infinity, and this is the negative side of x-axis, positive side of y, negative side of y. So when we are trying to ascertain the slope for x-axis, let us denote it by mx, this will be nothing but, so if I just write down the equation first, now which I have already written, so can I rewrite this equation as, now we know that if I choose any 2 points, let's say I choose any 2 points on the x-axis, and now I know the formula for slope, and this formula for slope is what? Delta y upon delta x. Delta signifies the change. So let's say y1 minus y upon x1 minus x. Now on the x-axis we know that there is no height. There is no height. No height means what? No change in the y component. But yes, there is a change in the x component. So if I divide 0 by a number which is non-zero, the answer will be a 0 only. So what is the slope for x-axis? The slope for x-axis is m is equal to 0. Thereafter, can I find out the slope for y-axis using the same logic? Yes. So the slope for y-axis will be, the formula remains the same. Now, when I'm using this formula, now I know on the x-axis, on the y-axis, x is equal to 0. Or another perspective is, even if I do not know what is the equation, then also I can infer. So on the y-axis, when you move along the y-axis, the height changes, but there is nothing like base. So the base does not change, or keeping the base constant. Now when you say keeping the base constant, that means there is no change divided by a 0, but the height definitely changes. Even if you do not know the equation by which you represent the y-axis or the x-axis, still this discussion can be completed as I am completing it for you. So now, if I divide a non-zero number by a 0, it cannot be written equal to something. You will say that this tends to infinity. Meaning thereby, the slope of y-axis, this side, I mean when you talk about this side which is the negative side of y, so here the slope of y-axis will tend to minus infinity. And when you talk about the positive side of y-axis, the slope on the y-axis will tend to plus infinity. But when you are talking about the x-axis, the slope of x-axis remains the same as equal to 0. Right? Taking this concept further, so what I am doing now is I am drawing a line which is represented by y is equal to x and y is equal to minus x. So let's say this line is y is equal to minus x, and this line that I am representing here is y is equal to plus x. So the point to understand here is the slope of this line is plus 1, and the point to understand here is the slope of this line is minus 1. So now you have all the segmentations of slope, and in my earlier videos we talked about when we are moving. So we always start, now we know this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So you will always move in a direction which starts from the positive side of the x-axis, and then you move in the anti-clockwise direction. That is how you ascertain the slope. So which is why you will see that in the first quadrant all the trigonometric ratios are positive. And why are all the trigonometric ratios positive in the first quadrant is because of the fact that the angle that you are taking is lesser than 90 degrees. So in that case, theta becomes what? The angle that you are taking in the first quadrant is lesser than 90 degrees, excluding the y-axis and the x-axis, which is why you say that the angle that you are taking is between 0 degrees and 90 degrees. So which means what? Acute angle. So whenever you are taking an acute angle, the slope will always be positive. So which is why you need to know that tan theta will be positive in the first quadrant, and at the same time it will be positive in the third quadrant. Why positive? Because the slope here is plus 1. So the point that we are trying to make here is the slope here is positive, the slope here is negative, the slope here is negative, the slope here is positive. And why is this happening? Because we know that x comma y here is x comma y is positive, both of them are positive, and here x comma y are negative. So when you are taking the rate of change, that is delta y by delta, that is how you find out the slope, which is why you will be able to say that in the first quadrant and in the third quadrant the slope of any line that you are taking will be positive, and when you talk about the second quadrant or you talk about the fourth quadrant, the slope of any line that would be drawn would be negative. This is very, very important when you are talking about coordinate geometry. And then further you can find out the limits of operation. Now when I talk about the limits of operation, so arrow to arrow. Arrow to arrow means that the points that we are talking about, we have excluded the x-axis, we have excluded the line which has a slope like 1. So can I say in this region, if there is any line that I am drawing, no doubt it lies in the first quadrant. So the slope would be positive. The slope will not only be positive, but it will lie between 0 and +1. Similarly, when I talk about the region between the y-axis and the line y is equal to +x, here the slope no doubt will be positive, greater than +1, but lesser than +infinity. Now the moment I keep on going this side, so now the slope would decrease because we have moved on to the second quadrant, and we know that in the second quadrant the slope is negative. So here can I say that the slope, it will decrease. Decrease means what? So now when I say it is decreasing, what do I intend to understand? So m will be less than -1, but it will be greater than -infinity. And further on it decreases, so it decreases further. So as I am going here in the second quadrant, so I'll say the slope is positive. The greatest positive slope is something that you can have on the y-axis. After this, the slope decreases till the time I go on to the negative side of x-axis. Now here the slope has to be negative. So negative here means what? And it is lying between 0 and -1. So this is moving towards 0. So from the negative side you will see it is moving towards 0. So from the positive side it came down to a -1, and from -1 it has come down to a 0. That means as I am going down the slope. So no doubt that the slope here would be negative, but here if I compare the line y is equal to -x, or if I compare the line y is equal to 0, which has a greater slope? Naturally this has a greater slope, because here as we go down the slope decreases. Okay, the same thing you can do for this side. So this table you can complete it for yourself. So what I want you to do is, there are 4 regions in which I have already specified the slopes. In these remaining 4 regions you need to find out their extremums, find out their limits. M varies between what to what is you are supposed to find out. So fill in these blanks and you can put it in the comment section. This is the homework that I want you to do.